Here is the rebuilt alternator. I've looked at the tag, and the gentleman who rebuilt it told me it's either 60 or 65 amp output now instead of 42 with the new stator winding. The tag, however, indicates it's 60 amp, which again is still more than enough to handle the electrical needs of the vehicle, which is what I was after. If I wanted something like 95 amps or more, I would have had to go to a newer style alternator, what they call a side terminal, as opposed to a rear terminal earlier generation alternator. It just wasn't worth it. We didn't need that kind of horsepower out of the alternator, but 42 was definitely, at best, marginal. And even then, only with the engine rotating about 2,000 RPM to keep speed up in the alternator enough to allow it to output that much. This particular vehicle has a very steep rear end axle ratio, 2.79 to 1. So 2,000 RPM, this car would be moving at about 60 miles an hour, 55 miles an hour or so. So driving around in city streets at 30, 35 miles an hour, the alternator would not have been turning fast enough for all 42 amps to come out, and that was the problem. It couldn't keep up with the electrical demand. It was draining the battery. This, we won't have that problem. So I have the alternator in hand. There were some retaining nuts on a few of the outputs and mounting studs. I've taken them all off. The field and stator terminals are not held in place by little mounting nuts on the threaded studs. They have push-on terminal connectors. The battery output is held, the terminal is held on by a large nut. So we have that, and then on the side we have a ground stud that is attached to the wiring harness itself with a lug that is threaded down with a nut also. I'm going to put this alternator in the general area of where it's going to go. Not lined up to install it yet, but just down there close to the wiring so I can get the wiring in place, and then I'll move the alternator up for installation. So hopefully Linda can get some of this. It's in kind of a clumsy area to work on and to video record. Not a bad situation, just a little clumsy. I've been in tighter spots before, but looking down here, you'll see the wiring harness. The battery output, the orange is field, the black with the white wire is stator, and the mounting lug for the harness is where my index finger is pointing. Those are all the things that need to be connected to get this hooked up. So I'll start moving some things around in the hope I can get all this in place without dropping anything. Just to point out, the negative battery cable is still unattached from the battery, so there isn't any possibility of me doing anything that's going to cause electrical damage or a short or ground circuit during this operation. That's pretty important. So I'll move the wiring off to one side. The alternator is going to end up being installed in this kind of position in general, like so. So in order to get to the back for the wiring, I'm going to set it down a little bit lower than where it mounts, try to hook up the wires and tighten down the mounting nuts, and then I'll move the alternator into place, I hope. These things are always a little bit dicey. And what's interesting is it's a fancy dance trying to get the alternator in a place where I can work on it without it becoming unstable and falling and putting undue stress on these wires. I don't want that to happen.
In case anyone hears a cat with a very sick meow,
It's not me.
We have our neighbor's rescue mama cat who was rescued from a country max. There she is walking. Got caught or got escaped and got caught in our garage, and we've got to have a heart with the neighbor trying to capture her. She wants no part of being carried over. She was thought to be feral, but she's not. But you cannot pick her up and carry her back to where she belongs. So if you hear a sick cry, it's the cat wanting out of our nicely air-conditioned garage.
Okay, so now I'm gonna try to push on the terminal for the field circuit. It went on fine. And now for the stator, way over here, I'm gonna try to get that pushed on if this lets me pull that far, and it is.
Did you hear a snap when they
I can feel it.
Okay.
I can feel it going over the stud. And now the battery terminal I will put into place. Now that takes a threaded nut to hold in place. I have the original one, plus when the guy rebuilt this, he provided me a new one in case this one got lost, and they do get lost. I have one sitting around here somewhere in the garage that I lost a while ago from the Mach 1. So I'll thread this on carefully. If I drop it, I'll just leave it lay and I get one of the new ones. Okay, I am getting some resistance in using the old nut. That tells me that the battery output stud put in the rebuilt alternator is a different thread pitch than the original output stud. So I used the one he provided. I'm happy to do that. And that one is threading on perfectly. The other part of this that has to go into place to make it all fit and work well is this retaining stud that isn't quite reaching with the alternator where it's at. So I'm gonna have to go ahead and try to line this up a little bit better than it is and see if I can get it to fit down here. I did. And then put its nut on. I suspect the original nut from the original alternator with the ground stud is different than the stud he put on here, so I'm going to use one of these new nuts that he provided me for the same reason as I did for the battery. I'm not trying to tighten these down yet. I just want to get them started. I'll run them down as far as I can by finger, and then I'll go ahead and tighten them up in a little bit before I put the alternator in final position. Unfortunately, where this nut is located is kind of an unusual position, and I am using my fingers and thumb to kind of feel around to make sure the nut's going on properly. And this one is not going on the way I was expecting. So I'm going to put this nut to one side, find the old original one, and see if maybe it's because he used the old stud, which would have been fine. It's just a ground stud. Nothing big going on there. And see if this will thread on. Without dropping it. It's just a very unusual situation I find this in. It does not feel like it's going on properly. So I'll move the alternator a little bit differently. Try this from a different position. I will go ahead and use one of the other new nuts he gave me. Let's see if maybe I can get it to work on here. And
Hi, Daisy.
I got it.
Hi.
So I'll get both of those nuts finger tight. Tighten them down using some what they call ignition wrenches. And once it's all tightened down and buttoned up electrically, I'll then go ahead and put the alternator into place. Now these ignition wrenches are small. They're actually called ignition wrenches. It's hard to see because there's so much dirt from many years of use on the pouch. But these wrenches were designed to primarily be used when working on the primary ignition system inside a distributor of old school ignition systems. Very short, very flat. Can't really put a lot of wrenching power on them because they're not meant to handle lots of strength. They're meant to be used in small, tight areas to tighten things up, tight enough to make for a good electrical connection. But there is no need to put a lot of torque on these nuts. In fact, that could cause problems. I'm having some challenges using this wrench. So I'm going to use a socket to get down to where I have to go instead. This is a 7/16 socket, and because of how I have the alternator just kind of hanging here, it is in a good position to use a socket like this. Much easier than the wrench I should have done to begin with. I don't have to over tighten this, just enough to keep it all in place. Over tightening could actually cause problems of a different kind. Now I need to get this little red hood moved up the output wire far enough to where I use the hood to cover that terminal. I have a cat below me looking up, watching as I'm working on this. So I guess I have a supervisor. Okay, I'm going to loosen this back up and move the terminal a little bit because the orientation of the outlet terminal lug itself is not quite where I want it. So this won't take a long time at all. Now maybe I can get this terminal cover in place the way I want it. There we go. Perfect. Now for the retaining strap. Now I have to make sure I have the right size wrench. This is not the same type that came with the alternator originally. It looks like it's the same size as what I have for the retaining strap. And I'll see if I can get that tightened down. It's in a very unusual situation, position-wise, where I probably could use a socket wrench on there too. But this is easier to get to than the battery output terminal nut had been. So I think I'll just keep using this ignition wrench, small one, to tighten it down. And once I have it tightened down, I'll have Linda come over and take a close-up of what I just did.
Yeah, I'm actually getting it pretty good.
Are you?
I get a good feel for where you are, yeah.
How about on the view?
Yeah.
Okay. Good. Nice and tight without being overly tight. So before I forget to do so, I'm going to take these two ignition wrenches and put them back in their pouch so I don't end up losing them. All the socket, quarter inch drive socket stuff I put away, out of the way. Okay, now the alternator is ready to be slipped into position where I can start to put in the mounting bolts, spacer, and the adjusting bolts. This is one of those things where it looks like it should be something really easy to do.
Do you want me to pause this and help?
Linda's going to pause this so we can start another clip.
Okay.
When we were off camera, we went ahead and secured the mounting bolt for the alternator up above. The bolt had to go through this dog ear, through this spacer. On the oil dipstick tube, there's a retaining bracket with a hole in it. It had to go through and then into this cylinder head mounting boss that's threaded. It sounds like it should be easy to do, but trying to get all this lined up, especially the oil dipstick mount, was challenging. So what I did is I went ahead and attached to this mounting bolt a pneumatic or air-powered ratchet. And as I was spinning that ratchet to the right using air power, Linda started to move the alternator around, trying to get all these things to line up. And the idea was I keep spinning that bolt. Once it caught the threads of the cylinder head, it would pull it in. And that's exactly how it worked out. Had that been a smaller diameter bolt, I would have run the risk of cross-threading and maybe snapping the bolt, but this is a pretty good sized bolt. So I knew that the likelihood of cross-threading the threads and the boss where it goes into, threads into, was very low. And it would be very, very difficult for anyone to snap that bolt. It is a very, very powerful, strong bolt. After we did that, we didn't tighten this down yet. I left it loose, a little loose. Down below, we have another mounting bolt going through an adjustment arm and into this lug, threaded lug on the alternator. And so I put the drive belt around the pulley. Had Linda, because she could do it easier than me, run the mounting bolt down but not tight, so it was in place. And then we wrapped a nylon rope around the housing of the alternator. And Linda pulled hard on that rope as I tightened down that mounting adjustment bolt below. Once that locked down, I made sure the belt had good tension on it, which it did and still does. So after I tightened down the adjustment bolt on the adjusting arm lug of the alternator and verified the belt tension was still good, I tightened the top mounting bolt and snugged it down, and I rechecked the tension of the belt, because sometimes when these things aren't tight, tightening it down can alter the geometry a little bit of the brackets and the device being mounted. Then the other end of this mounting bracket for adjusting connects to a small bolt back near the water pump. So I had to check that bolt to make sure it didn't loosen up during this whole process. So I tightened it, let's see, about 40 degrees. 40 degrees, how did I know that? Well, it's a 12-point socket, so once I had the wrench in place, I could turn it to the right, but not very much. When I did, I was able to move down one set of teeth on the wrench. They are 30 degrees apart. I was able to move it a little bit more before it was really tight again. So I knew I had at least a 30-degree turn and a little bit more, so I'm saying 40 degrees, and I was in. So after I did that, I went to the back of the alternator to make sure that this insulating cover over the battery post of the alternator was still in place, and that the wiring was still not touching anything metal, because even though it's insulated, metal will rub through insulation and cause a short. And I made sure we still had lots of room on this wiring harness. And the reason that's important, as the engine is running, it's mounted with 2 engine mounts to the subframe of the car. But they are not solid mounts. They're rubber in between metal. And so as the engine's running, the engine will rock a little bit in here. As it does, it could put stress on a wiring harness if it's not allowing enough movement. And that could cause electrical problems with the connector. So I made sure all that was in good shape. So my next step, before I put all this back together, is to put the negative cable back on the battery. After that, I'm going to do some more testing of another device. What am I up to? Well, originally I had 2 devices to control the cooling fans. One is a thermal control switch, where I have a capillary tube that goes underneath and between the radiator hose and radiator hose inlet for the radiator, and has a small thermocouple inside this hose to measure the heat of the engine coolant. When it hits whatever temperature this dial tells it to wait until, it'll cause this to go ahead, close 2 contacts, and send voltage from here to here. This is a fan relay, but I've replaced it with this special kind of relay. The relay will take relatively low current voltage, which is battery voltage, but it's low current, only a couple of amps, and it causes electromagnetic coil to pull a disc down that will make a connection between a high amperage input and high amperage output and send higher amperage power to the fans. So the fans, when they pull their 14 or 15 amps of current, isn't sending 14 or 15 amps of power through the thermocouple control switch. It sends it all through here. But what I wanted to do is have the fans keep turning after the engine is turned off for a little bit of time to help cool down the coolant in the radiator. So this has a built-in delay that is adjustable between 2 seconds and 3 minutes. And that's adjustable through a weather seal here. And inside there's a small adjustment we can make with a small screw. Now I don't know what it's set for right now. So I'm going to test this and see if I can figure out how long the delay is. If it's between 30 seconds and 2 minutes, I'll leave it alone. Otherwise, I'll start to adjust this so I get the behavior I want. So now I'll go ahead and tuck this delay relay out of the way. There's nothing fancy about that. It can sit right here. We aren't going to be driving this car in the rain, so I'm not worried about rainwater getting in there. So now I'll put the negative cable on the battery and tighten that down, and then I'll proceed to test the fan delay and relay. So the negative cable lug end is on the post. Now I get my battery pliers, and they're actually called battery pliers but made for this, and I'll start to tighten down the nut on the battery terminal. It doesn't take a whole lot to tighten these things down. We don't want to make it so tight it's hard to get it off later in case there's a problem. Doing this with one hand, holding a light, one hand on the pliers, is making things a little bit more challenging than usual, but I'll get there. I'm in no big hurry.
It's also raining out, so we're not going anywhere with the car.
Okay, that's fair. Now what I do is I test by trying to twist the battery cable lug. I try to turn it on the post to make sure it doesn't turn. It's not turning, so we have a good tightness there. So now to turn the fans on, I wired this quite intentionally where the trigger side voltage is coming off of battery voltage, not switched voltage. And that was so this could keep running after the car is turned off to cool down the temperature of the coolant inside the radiator. So I don't have to start the car to test this. What I'll do is I'll turn this dial down to a temperature that is a lower trigger temperature than the coolant. The fans will come on. After they've run for a few moments, I'll turn this back up so it shuts this off. I'll be able to hear it click. The fans should keep turning for between 3 seconds and 2 seconds and 3 minutes. I don't know how long yet. I'm gonna time it. I've got a little stopwatch right here built to my iPhone, as I want to know fairly precisely what's going on. So I got my stopwatch feature turned on, ready to go. If I'm not careful, I'm going to drop the iPhone. I don't want that to happen. I'll move a few tools. Okay, first I turn the fans on.
Click.
I heard the click. but this didn't turn on. Okay, I'm going to go off camera and see if there's something with the wiring from this relay and the previous relay that needs to be attended to make sure everything's working the way it should. So in the previous video clip, I was starting to test the new delay relay for the fans, cooling fans, to make sure that the relay was working and it would have a delayed shut off. Lo and behold, the fans wouldn't turn on. So I checked the wiring. These relays typically all have the same kind of terminal positions. This is known as a Bosch relay terminal setup. They're all three the same. I checked on the side of these units. They identify which terminals go to which kind of voltage. Now here, that white stuff has been rubbing off. Luckily for me, being clever, I went ahead and took a picture of that back when the ink was very clear. So I used that to make sure I was getting proper voltage for constant voltage, trigger voltage coming in, going off, using a test light. Everything was working as far as the wiring matching the schematic. So I had Linda get me the two older relays, the one that was in use. This one is a delay relay, but when I got it, lo and behold, I looked on the side and it says 10A on here. That's 10 amps. I need something at least 15 amps to carry the load of these two electric fans without causing potential damage to the relay. So I ordered this unit. It's a 30 amp delay relay, except it's not working. I'm going to get a hold of the seller, ask them to exchange it. Hopefully the new one works. Meanwhile, I'm going to use a 10 amp delay relay. And the reason I think I can get away with that, even though it's made for 10 amps and I'm pulling 15, and I measured how many amps the other day on the video and did a little bit ago just to make sure it was consistent. It pulls 14.9, we'll call 15 amps. Well, when these things are made and they state the capacities, often they will understate how much these things can really handle. So between now and the time I get the replacement 30 amp delay relay, I'm going to use a 10 amp one. It's functioning fine. I ran it for a while. Nothing seemed to be overheating or anything else. And as far as testing it for delay, I wanted about 1 minute thereabouts of a delay. So I went to my little stopwatch on my phone. I'm going to turn the fans on, turn them off, and start the timer and see how long it takes now to turn off. I've made my adjustments. It should be just under 1 minute. Fans on. Fans off. Boring, sorry. Halfway there. Now I took about a second to hit that little button, so this will probably be a second and a half lower than how long it really took to shut off. Any moment. Okay, so it'll stop in about 57 seconds. And that works fine for me.
Explain the idea why we wanted this.
I want the engine, when we come to parking lot or the garage, we shut it off. I wanted the fans to keep cooling off the coolant inside the radiator just for a little while. And once it cools off, I wanted the fans to turn off. I didn't want the fans to be running for a long period of time. So that's the whole idea behind this. Now, we'll see how all that works out. I see where there is a potential logic flaw in how I am triggering this thing, the delay relay, where it might be that this has to cool off below what my setting is, which is typically 200 degrees. So it could be that it'll take more than a minute to shut off, but the idea is it won't keep running and running and running and running. So that's the thinking behind it. So I have never run across a relay brand new like this that failed. I did try to adjust it to see if maybe it was adjusted way too low or too high. I put it right in the middle of its adjusting setting, so it should have been about a minute and a half or so delay if it worked. The other two work.
Yeah, we didn't even get the fan to turn on with it.
Wouldn't even come on. So before I say, hey, we can start cleaning up, I'm going to check one other thing. This coolant overflow tube, little container, I want to see if there's any coolant in there. There should be some. Don't know how much, but should be some. Well, that's a lot of turns. Down near the bottom, I could get the light on, but there's coolant near the bottom. Might be about an inch deep. When the radiator warms up, the coolant expands. It'll go out the overflow port of the neck of the radiator through a hose that goes into the bottom of this thing. It'll come out the top of this tube, and this will fill up, and it'll hold the reserve fluid. When it cools off, rather than sucking air back in the radiator, the cap will suck coolant from here back into the radiator. So we aren't spilling or wasting coolant, which is no big deal, but the whole idea is warm or cool, I want that radiator to be as full as possible. Now, this little adjustment for the temperature control for when the fans come on, there's a hazard with this. Anyone who might have been watching carefully saw this. As I was loosening and tightening this, my thumb, the back of my thumb, touched this and moved the dial. Not much, just a little bit, but I didn't want it to move, so I double checked, made sure it's back on 200 degrees. Now, I haven't checked to see if this 200 degrees really works or not. If 200 degrees here is the same as 200 degrees really coming out. We do have an infrared thermometer, so I could test that, and I will. I'm not going to do it now because we had to back the car out of the garage to do that, so we don't get gassed with exhaust fumes. But it's raining outside, so I'm not going to move this car anywhere outside today.
And the top's down.
And the top is down, which is unfortunate because I really wanted to go ahead and test the output of the alternator. We'll do that in another clip following this one up. We'll hook up the VAT40, fire it up, and test the output of the alternator and make sure that we're getting enough to handle all the electrical load and then some on this vehicle. We've gone from a 42 amp output to 60 to 65 amp. That would be plenty additional amperes to handle electrical needs for this car, all of them. Okay, we'll be back. Well, the weather looks good enough to pull the car out. I don't think it's going to rain anytime soon. So now we're going to go ahead and test the rebuilt alternator, the new high capacity amperage windings. I've hooked up the vent 40, positive, negative, inductive ammeter. What I'll do is I have Linda hand me her phone as I watch the meters here. I'll have her start the engine, turn on the air conditioner on medium fan, and that will have the primary ignition system on. Headlamps, parking lights are on anytime the car's running automatically. Air conditioner and blower on with air conditioner blower at medium speed. The LED tail lights sequential turn flasher circuit will be active. And last time I did that, it was drawing about 35 amps. And the alternator was outputting a net of about 1 or 2, maybe 3 amps at 2,500 RPM. It was marginally enough to keep the battery kind of charged, kind of. So now I'm gonna see what the output of the alternator is now that it's been rebuilt by having Linda load it up. I'll put extra load on the system and see what the total output is of the alternator. Now that is going to be a net reading, output minus what's coming back, what's coming out of the alternator going into the battery when it's coming out for the circuits. So the actual output will be higher than what we're going to be measuring. As long as we're over 50 amps total, I'm good. So with that, I'll have Linda hand me her phone. I have her start the car up and hold it about between 2,000 and 2,500 RPM. Okay, so we have about 35 amps being drawn. I was getting about, after review, looked like about 16 amps on top of that.
Is that good?
So we're getting just over 50 amps total, which I'm fine with. We're getting enough additional amperage out of the alternator to keep the battery charged. I had the fans, I set them so they turn on, they're still running. Everything else was turned on, so that was near maximum load on the electrical system. So I'm very pleased with what happened. Back to Linda, I'll have her turn this off.